Chapter 4. In this chapter, we'll take a look at the ability to create comparisons and to make alternate actions, as in the idea of an if statement and some other new structures as it relates to making decisions within a program. So we'll start out with the relational operators. They are almost the same from our previous experience. Remember, the relational operator is used to compare two things. Are they less than, greater than or equal to, less than or equal to? What we need to understand, there are two new symbols for us, and that is the equals. It's two equal signs. The single equal sign, remember, is the assignment operator. It is used to assign from right to left, and in the more recent languages, we don't use that for the comparison like we did in BASIC. You use a double equal sign to compare as to whether or not A, is equal to B. So this is what's going to return that true-false comparison. And then the not equals to, and I alluded that when we were looking at the opening and closing symbols that we use for the file streams and things like that. The not equals to is using the exclamation point, which is actually can be a standalone. This is the not operator, and it's the negation operator. So it allows us to negate an expression, and we'll look at that one a little bit later on when we use the logical operators. But not equal to is the exclamation point with an equal sign. What we need to understand is that all relational operations return a Boolean expression, which we should already have that understanding. That is it true or false? Is this less than that, true or false? So is 12 greater than 5? We know that to be true. Is 7 less than or equal to 5? We know that to be false. So it returns this Boolean value of this true false. And so again, if x is equal to 10, is x equal to 10 is true. Take notice. Double equal sign is what we use. Otherwise, it does assignment. Not equal to, that is true, that x is not equal to 8. Is x equal to 8? We know to be false. So we can assign a variable, okay, the value of a test expression. So this is the test expression. Is x less than or equal to y? We know from our data type, the bool data type, it is a value of 0 for false and 1 for true. And so I can assign this Boolean value to a variable, an integer variable or a bool variable. And so if this were true, it would assign 1 to result. Otherwise, it will assign 0 to result. Okay, and again, don't confuse the equals assignment to the test of equality. All right, there's a difference between the two. So let's talk about the if statement, the structure of the if statement. So we know that the if statement allows for a condition to occur. All right, so if it's raining, we're going to take an umbrella. If it's cold out, you're asked to wear a coat. So the general statement for a single if statement is we have the keyword if. It is lowercase. It's important to understand. And then the expression. This is the test expression. It must be in parentheses. Okay, it must be encased in parentheses. And then we get the final statement as to what do I want to happen if the expression is true. And take notice the semicolon is here at the end of the executing statement, not at the end of the test. We do not put the semicolon at the end of the test. So we evaluate the expression and the statement. If the expression is true, we will execute the statement. If the expression is false, then the statement is skipped. Now, we have to remember we don't have line numbers. And so when we look at our test, okay, we need to understand that by default, okay, by default, it takes one line of code for the if statement. So if average is greater than 95, it will print out, congratulations, that's a high score. If it's false, then this cout statement gets ignored. Now, remember I told you the semicolon does not go at the end of the if statement. If I put a semicolon at the end of the if statement, then it ignores the test and the cout statement will still execute. So it's important to understand there are places where semicolons just don't go, and this is one of those places. Where it does go is where do I want the statement to end then, that action. Okay, so this one is allowing for a single test. So some things, do not place the semicolon at the end of the expression. That's very important. We always place the statement on a separate line and it's indented. Now, what I need you to understand is that white space is actually ignored. All this white space that you see throughout is ignored by the compiler, but we do it for readability. I could put this all in one line and it would still work. We do that for readability, for understanding, and we talked a little bit about that in the previous chapter. So again, it takes one line by default. It gets the semicolon at the end of the execution. It is very iffy to test floats and doubles because it doesn't quite know at what point do we say it's close enough. Okay, so we generally do not test floats and doubles in this scenario unless I've put in a measure of how far out am I willing to go to say that they're equal with a place value. Remember, 0 is false, otherwise anything else is considered true. No matter what it returns, it would be true. So that's a single if statement. What if I wanted to do more? So then if an if statement says, oh, I want to do this, but I also want to do this, this, and this, that kind of a honey-do list of items it wants to do. And we didn't have that back in BASIC because it was such a simple structure, simple language. I can do multiple things if something is true. This is where our curly braces come in. Okay, since we don't have line numbers and things like that, this is where the curly braces come in. So here we have our test, again, no semicolon. So if score is greater than 90, if it's true, then it will execute that grade is equal to uppercase character A, and it will also see out good job. All right, this creates what we call a block of code. So this whole block of code will execute only if the test is true. Okay, otherwise this whole block is ignored if it's false. So if it's false, it will drop to whatever is outside of the curly braces, that next executing line of code. Now, what if I want an alternative action? We have the if-else. So this provides two possible pathways at execution. Okay, so it will perform one set of statements based on the trueness of it and the other based on the falseness of it. Okay, so here we have test expression. These statements occur if this is true, and these statements occur if the expression is false. Okay, so one of two actions would absolutely take place under this condition. Okay, so again, it takes one line by default. If I want multiple lines, I need to create a block with curly braces. So that's the idea of or a block, the comment of or a block. So here we have the idea if test expression is true, then statement 1 will execute, and statement 2 is skipped. It will only choose one or the other. If the expression is false, then statement 1 will be ignored and statement 2 is executed. So let's take a look here. So the idea is that in this program here, we declare a number int, we enter an integer, and they'll tell you whether or not it's even or odd. And so if number mod 2 is equal to 0, if this is a true statement, the number is going to be even. If it's a false statement, it's going to be odd. So let's say the user enters a 9. Well, if we think about 9 mod 2, that's going to return a remainder of 1. okay, because it goes in 4 times with 1 left over. Okay, so is 1 equal to 0? No, it's not. So I can include an expression in with the test. So if the expression evaluates, okay, that will evaluate first. If it's equal to 0, it'll produce that. But we know 9 to be odd, so the outcome will be it's odd. If I would have entered a 10 and did 10 mod 2, it will ask whether or not 0 is equal to 0, and that would report out for us that it is odd. So this is a basic if I shared with you, and then an if-else statement. I can still frame this out with a block using curly braces if I had extra things that I wanted to execute.